So what we were working on last week, we were talking about completing the square, right? And it's just the next step in quadratics. And the next time I see you, I will show you how we get the quadratic formula by using completing the square. Where we get the quadratic formula that you'll start using next came from the idea of completing the square. And ultimately what we do is we create perfect square trinomials, right? So that we can take the square root of both sides. So we were solving problems before where we would have like x squared plus 4x plus 4, which is a perfect square trinomial, right? Because I know that this being a perfect square and this being a perfect square, I could break this down into x plus 2. I could take the square root of this plus the square root of this and square it, equals 49. And then I can go ahead and just take the square root of both sides and solve it. And I get x plus 2 equals plus or minus 7. And then break it down into the 2. X plus 2 equals 7, and x plus 2 equals minus 7, negative 7, and then I can solve, right? Subtract 2, and I get x equals 5. Subtract 2, and I get x equals 9. So what we're doing is we are going to do what's called completing the square. And all it really is we are taking whatever trinomial we're given and we're going to create these perfect square trinomials so that we can do this, right? And there are steps that we're going to take in order to make that happen. So I'm going to start with, for example, x squared plus 10x minus 96 equals 0. And over here on the side, I'm just going to kind of list the steps as we go. You'll see them in the Edpuzzle as well. So pay particular attention when you're watching the Edpuzzle, because your Edpuzzle question, the one that you have to solve for points, will relate to the steps. Okay? So make sure to take notes when you're watching the Edpuzzle. And I even put a note in there for you to do it. So the first thing that we're going to do is, this is 10x minus 96. The first thing that we want to do is move our non-x term, our constant term, to this side of the equation and have all our x's. So we want all our x's on the left, and we want anything else, all our numbers, on the right. So the first thing we want to do is move constants, right, or C terms, constants, to the right. And all x terms, right, whether it be x to the first power, x squared, whatever, we want those on the left. So the way we're going to do that is, in this case, the only thing we have here that's not an x term on the left is this minus 96. So we're just going to add 96 to both sides of the equation. And then here we will be left with x squared plus 10x equals 96. Our next step doesn't apply to us right now because our a term, right, if we're talking about ax squared plus bx plus c, a is what would happen in front of x squared. If it's not a 1, we need to divide by a. We need to divide every term by a. So doesn't apply here if x is 1, because if we divide every term by 1, everything stays the same. Divide by a if necessary. Not necessary in this case. So we're going to move on to the third step. And the third step is we are going to take half of b, square it, and add to both sides of the equation. Add to both sides of the equation. What does that look like? Well, our b term is whatever is in front of our x. So in this case, our b term is 10. And it says we're going to take half of it. So I'm just going to come over here to the side and I'm going to go 10 divided by 2. And then it says we're going to square it, right? So 10 divided by 2 is just 5. So we're going to be left with 5 squared, which just equals 25. So what does it say to do with that? It says to add it to both sides of the equation. So I'm going to add 25 here, and I'm going to add 25 here. What it gives me is this perfect square trinomial like we had in the first place, which means that I can write this as the square root of this term, which is just x, right? Because it's x times x that equals x squared, plus the square root of this piece, right? Square root of 25 is just 5. And then I square that, equals 121. And now I can solve, right? I can solve by taking the square root of both sides. So 4, solve by taking square root of both sides, right? So when I do that, I'm just going to pop one of these on each side. And here I'll just be left with what's inside that parentheses, right? I'll be left with x plus 5 equals the square root of 121 is plus or minus 11, right? 11 times 11 equals 121. They won't always be perfect squares. You'll still have to solve them, and not with decimals. So here we have x plus 5 equals 11, and we have x plus 5 equals negative 11. And we go ahead and we just solve these equations, and we should get our 2 solutions. We're going to subtract 5 from both sides, and here we will get x equals 6. And we're going to subtract 5 from both sides, and here we will get x equals negative 16. Did that make some sense to you? Okay. Well, we'll do a couple more. Like I said, we'll get so that you have an example of every facet of this that you're going to come across in your homework. The difference in your homework is there are a couple where you actually have to move the equation around before you start, right? But I'll show you a little bit of what I mean by that. As a matter of fact, I'll do it on this one, the way I write this problem. So say I have 3x squared minus 45 equals 6x, right? Well, if we look at this first rule, the first thing we have to do is move the constant to the right and all the x terms to the left. So we need to get this 6x on this side, and we need to get this 45 on this side. And it's pretty simple math, right? I'm just going to subtract 6x from both sides, right? Which would give me 3x squared minus 6x minus 45 equals 0. And now we can move the 45 over, right? So I can just add 45 to both sides, which is going to give me 3x squared minus 6x. I'm going to leave a little space there because I know I've got to add something to it, equals 45. And now we're good to create these problems, right? The next step, it says, well, if my A term is not is not 1, then I have to divide every piece by A, right? So I'm just going to go through. A is 3, so I'm going to divide this by 3, this by 3, and this by 3. And I'm going to get x squared. 6 divided by 3 is 2x equals 15. So that's step 2. Step 3 is where we take half of our b term. Our b term is now 2, so negative 2. So I'm going to go negative 2 divided by 2, and then I'm going to square it. Well, negative 2 divided by 2 is just negative 1. Squared just equals 1. So I'm going to add 1 here, and I'm going to add 1 here. I'll do it in a different color so that you can see that they were added after the fact, right? That's what we changed. And so when we go to write this, we get to take the square root of this term. Because this is negative, we're going to be minus here. If it was positive, we'd be plus here. So we've got x minus 1 squared equals 16. And so now we've gotten to that part. We've done all of step 3. Step 4 says that we need to take the square root of both sides to solve it. So we're going to put our little square root symbol over both of them. And here we're going to be left with x minus 1 equals plus or minus 4, right? The square root of 16 is just 4. And now we can solve our 2 problems. We have x minus 1 equals 4, and we have x minus 1 equals negative 4, right? Plus or minus. So we're just going to add 1 to both sides, and we get x equals 5. And we're going to add 1 to both sides, and we get x equals negative 3. 2 solutions, right? Feel good? So we added one more step this time. We had to divide that a term out. And we also had to put it in order before we could even start. The next one, and it will be the last one, I just wanted to make sure that you had one that had a fraction in it, because we haven't seen something like that. You will come across it in your homework. So I wanted to make sure you had it. I think I will write it again where we have to put it in order first. So if I have 2x squared equals x plus 3, right? I need to get that x over, right? So to do that, I'm just going to subtract x from both sides. I don't need to move the 3 over because I want the constant on that side anyway. So I would get 2x squared minus x equals 3. Now, I still have a non-1 in my a term, right? This isn't 1, which means I have to divide everything by 2, each piece. And here I get 2 over 2, which is just 1, so that becomes x squared minus, you can write this as negative x over 2, or you could write it as negative 1/2 x, which is how I like to write it, equals 3/2. So this is where it gets ugly. This is, like I said, the ugliest problem that you're going to see. I can't believe I'm not even on camera. No wonder no wonder I'm not videoed in this. So the ugliest thing that you're going to see is something like this, where you've got a fraction, right? Because we have to take our b term, right? We got to do b over 2 and square it. In this case, our b is negative 1/2. So we've got negative 1/2 over 2, and we need to square it. Well, this is kind of the same as saying 2 over 1. Do you guys remember how to deal with a fraction like that? It's a division problem. Do you remember how to divide a fraction by a fraction? Well, it becomes a multiplication problem. So if I have negative 1/2 divided by 2 over 1, I could write it as times the reciprocal of this, which just means we flip over that bottom fraction, right? And we would get negative 1/4, right? So this becomes negative 1/4 squared. And when we square that, we square every piece of it. So it just becomes 1 over 16. It becomes positive because negative times a negative is a positive. So if we're doing negative 1/4 times negative 1/4, we get positive 1/16. And so that is what we are going to add to both sides of this equation. We are going to add 1/4 here, and we're going to add 1/4 here. I don't know why I'm doing 1/4. I meant 1/16. I think I was still looking at the 1/4 that I squared. So we're going to add 1/16 to both sides, right? And here, when we rewrite this, we get the square root of x squared is x minus, because this is a negative, and we're going to take the square root of 1/16, which we already know is 1/4 because that is how we got it, right? And we're going to write that as a square. Equals, well, we have to add these fractions together. What do I need to add two fractions together? Common. Thank you. Yes. And in this case, our common denominator can just be 16, right? Because 2 goes into 16. So if I have 3 halves and I need it to be 16, I'm just going to multiply times 8 over 8, right? 2 times 8 equals 16. And I get 24/16. So if I have 24/16 plus 1/16, that would give me 25/16, right? Right? If this became 24/16 and I'm adding it to 1/16, I get 25/16. And I like that. And the reason that I like that is because it's going to make this math a whole lot easier, right? Because I'm about to take the square root of both sides. And when I do that, this is going to give me x minus 1/4 equals plus or minus the square root of 25 is 5, and the square root of 16 is 4. So it's plus or minus 5/4. So the reason I like that is because we have common denominators here, right? So when I add 1/4 to both sides, we don't have to find common denominators because they're already common. So when I write my two equations, I wind up with x minus 1/4 equals 5/4. And I get x minus 1/4, plus 1/4 equals 5/4. And then we go ahead and just solve for x on both of those. And the way we do that is we're going to add 1/4 to both sides, right? So this gives me x equals 5/4 plus 1/4 is 6/4, which we can reduce, right? Because each of those are divisible by 2, and we get 3 halves. Here, when we subtract, there we were adding here. In both cases, we're subtracting. I don't know. I'm losing my mind here today, right? I don't change this. I change what this is equal to. So now I have minus 1/4 equals minus 5/4. So I'm going to still add 1/4 to both sides. And I'm going to get x equals, well, now I have minus 5/4 plus 1/4, which gives me minus 4/4, which is just negative 1, right? 4 over 4 is just 1, and we got a negative there. So our two solutions are going to be x equals 3 halves and x equals negative 1. That will be the hardest type of problem you have to do, because I know that fractions make you all panicky, but that's as hard as it gets, right? Everything is just creating these perfect square trinomials. Then you take the square root of both sides and solve for your x, right? Any questions regarding that? I know it's hard to have questions until you've practiced it a little bit, and that's what your Edpuzzle and worksheet are for. But do you guys have anything for me before I end this? Well, I'll end the video now.